So my name is Tim. I'm part of the MathWorks Startup Program. I cover the western states of the US, and I'm here at the Capital Factory to talk about this demo that we have here, where our goal is to help startups kind of accelerate their workflow, to help them realize prototypes a little faster with the tools that we have available. So here we have a robotic arm. It is being controlled by a Simulink simulation, a model that is created in Simulink here, where all the controls are created in this model here, from the image processing side, the motion path planning, the recognition of the objects that it's going to plan to pick up, etc. Those are all modeled into this software model. And it is now running, that model creating the controls are now running on this robot. So we have all these options of pick and place that we virtually create and label. And the gripper is currently picking up these virtual objects and labeling them and putting them in the appropriate bin. So the special thing about this demo is that it's not limited to just a robotic application. So MathWorks tools are pretty broad in scope that can cover things like wireless modeling. It can cover physical modeling, hydraulic fluids, electrical simulations, motor control, image processing, adopting AI models and integrating them into this physical hardware model.
Awesome, Tim. I really appreciate that. Can you share about kind of what's in the computer?
So on the computer, we have the different aspects of the model. So most people are familiar with just writing code to control something. Control development, controlling hardware, just code by itself is not the most intuitive way to visualize a control engineering problem. Usually this visual approach is much more intuitive and easier to scale up and develop. So in this case, we've developed this model such that we have the object detection portion of the screen. We've got the motion planner, the supervisory control, the robot gripper feedback, and then visualization of all these parts in there. We have access to all the APIs of the camera, the planner, and the robot. And when we click run, it will run this simulation on the robot. It can also generate C code to deploy to any controller of your choice. So that's a very common use case for industry, where they develop the model within Simulink, and then you can target any hardware that you choose. Suppose you're going on a drone, onto an excavator, onto embedded hardware, a PLC. All this can be done with our platform here.
So you're basically making easier to program these robotic arms, which are very challenging to be programmed, right?
That's right.
And what you will say is the biggest challenge when programming a robotic arm such as this one?
Yeah, so most robotic arms that you purchase like this, they usually come with a set of controls from like the motion controller that you buy from the manufacturer. Our software allows you to increase the power and scope of those controls. So when you have things like things that are not motion related, sometimes the manufacturer's controls are not as robust. We are able to offer a larger scope of control for that. The largest challenge would be really the development of the hardware and also the motion planning. Usually the manufacturer also offers a solution for that, but we can also do that on our platform while linking a lot of different types of physics together with them.
Super interesting. I really appreciate your time, Kim.